Hi there. Can folks hear me now? Oh, okay. Sorry about that, folks. Okay, we'll sort of get this started again. Okay. Thank you for speaking up, Christopher. Okay, so has everyone sort of followed me up until this point where I did the bivariate crosstab? I'm going to take that as a yes. So what we're going to, so when we did the bivariate crosstab, we looked at the relationship between the sex of the respondent and willingness to live common law, right? And we found a gap of 26.4 percentage points. Men are 26.4 percentage points more likely to be willing to live common law than women. But because we know that religious observance, religiosity, might also be related to willingness to live common law, we should probably control for that, just in case the gender gap is different at different levels of religiosity. So this data set conceptualizes religiosity in terms of how often one attends religious services. So religious service attendance is coded as 1. If somebody goes to a religious service at least once a week, it's coded as 2 if they go less than once a week. So we can do a trivariate crosstab that controls for the effect of religion the same way we do a regular crosstab, by going analyze, descriptive statistics, and then crosstabs. And we have our dependent variable or y variable in the rows, so that's willing. Our independent variable or x variable, which is the sex of the respondent, that's in the columns. And we're going to put our control variable, sometimes known as a moderator variable, in the layer field here. So our control variable is RL_attend, which we will stick in the layer field. And again, make sure cells column percentages is selected, press OK. And now we have a crosstab that has 2 partials. It has a partial crosstab for those who attend religious services at least once a week, and then a partial crosstab for those who attend religious services less than once a week. And then it has a full crosstab for both of these categories combined. Now, recall, in our original crosstab, 62.2% of men were willing to live common law versus only 35.8% of women. So that's a gap of 26.8 percentage points. If we look at just those who are religious or who attend religious services at least once a week, we see that 26.8% of men are willing to live common law and 9.8% of women are willing to live common law. That's a gap of 17 percentage points. However, if we look at those who attend religious service less than once a week, we find that 68.5% of men are willing to live common law and 43.3% of women are willing to live common law. That is a gap of 25.2 percentage points. So we see that the size of the gap has changed. So there was a gender gap of 26 points. There still is a gender gap once we control for the effect of religious service attendance. But amongst the religious, those who attend religious services at least once a week, the gender gap has decreased from 26 to 17 points. However, amongst those who are not religious, the gender gap remains 25 points, which is basically unchanged from 26 points. So after controlling for the effect of religious service attendance, we find that the size of the gender gap changes, right? It's different in the different partial crosstabs. So what can we infer from this relationship here? Does religion have an effect on willingness to live common law? And what is the nature of this relationship? I'll give folks a chance to respond either by unmuting yourself and saying something, or you can just type something in the chat interface. So because the partials are different from one another, so the original gap has changed depending on the category of our control variable. We see a split, the partial crosstabs have split in their relationship. And that means one of the partial crosstabs is stronger or weaker than the other. So the religious folks, this partial crosstab, the relationship is weaker than non-religious folks. And so this would be an example of an interactive or interaction effect, where religious service attendants and the sex of the respondents interact to produce different probabilities in terms of willingness to live common law. Yeah, so this would be an interaction effect. So let's do another example together here. And there's other variables here. We see, there's education. Education might have an effect. We know that folks with higher levels of education tend to be more socially progressive or morally permissive. And so that might change the calculation as well. So let's do another trivariate crosstab, except this time we're going to control for the effect of whether or not somebody has any post-secondary education at all. So let's go to analyze descriptive statistics. We're going to go to crosstabs. And again, keep willing in the rows and sex in the columns, but our layer, we're going to get rid of religious attendance. And instead, we're going to put this has PSC variable in here and press OK. So again, recall the original gender gap is 26.4 points, right? Men are 26.4 percentage points more willing to live common law than women are. However, we see that once we control for the presence of any post-secondary education, the relationship changes again. So amongst those with a high school diploma only, so no post-secondary at all, we see that 62.3% of men are willing to live common law versus 37.3% of women. That gap is 25 percentage points. Amongst those with any form of post-secondary education, 69.7% of men are willing to live common law versus 51% of women. So that gap is 18.7 percentage points. So we have a gender gap of 25 points amongst those with a high school diploma, and a gender gap of only 18.7 points amongst those with any post-secondary education at all. So again, we see another example here of a split in the partials, where this partial has the gap at one level and this partial table has the gap at another level. And so we can conclude here, because the partials are different from one another, that this is another example of an interaction or interactive relationship between X, Z, and Y. So I'll give folks just a second if they want to ask any questions there. Does anyone have any questions of these two examples? Okay, seeing no questions, what we'll do is I'm going to close this GSS 2001 data set. And now what I want you to do is, if you haven't already, I want you to go to D2L, to the content and then lab materials section, and download this 2015 Canadian election study for tutorials data set. So this study is conducted after every federal election. They interview about 6,500 respondents, and it's sort of the main data set that Canadian political scientists who focus on voter behavior and public opinion use for their research. This is a condensed version of it with a few different questions which I thought might be interesting for us to analyze in the next few weeks. And so when you open it up here, you'll see 28 questions. And the sample problem that I'm going to give you here is, are religious folks more likely to be right-wing, right? So, you know, there's this supposed relationship between in higher levels of religiosity and increased identification with the conservative or the right-wing end of the political spectrum. And so, you know, our research question is that, you know, might be, is there a relationship between religiosity and conservative ideological identification? So we have questions here that we can use to test that. So we have this right-wing variable. So this person identifies as right-wing, and so it's coded as 1 if somebody identifies as right-wing, and it's coded as 0 if somebody identifies as left-wing or centrist. And how this question works is they ask people, you know, on a scale of 0 to 10, where 0 means very left-wing and 10 means very right-wing, you know, where would you place yourself? And we have another question, religiosity. So that's the importance of religion. So this is coded as 0 if religion is not very or not at all important to somebody, and it's coded as 1 if somebody thinks religion is very or somewhat important to their life. So let's do a bivariate crosstab. So we'll go to Analyze, Descriptive Statistics, Crosstabs. And you can see the last practice problem I did there. So our dependent variable is right-wing. We'll put that in the rows. And our independent variable is religiosity. So we'll put that in the columns. And as usual, we want to go to cells and select column percentages. So if you press OK, it'll run the crosstab for you. And so we see that amongst those for whom religion is very or somewhat important in their life, 36% of them identify as right-wing. And then amongst those for whom religion is not very or not at all important, 25% of them identify as right-wing. So this ideology gap or this religious gap in right-wing ideological identification is 11 points. So religious folks, or those for whom religion is very or somewhat important to their life, are 11 percentage points more likely to identify as right-wing than those for whom religion is not very or not at all important. However, maybe it's more complex than just religion and ideology. We know that education is another variable which is related to both of these, where more or people with higher levels of education are both more likely to identify as left-wing or centrist, and they're also more likely to be non-religious. And so we should probably control for that. So we can do that. We have a variable here. Where is the education one? Uni degrees. So this is uni degree, and it's coded as 0 if somebody does not have a university degree, and 1 if they have a bachelor's degree or higher. So let's go and run that Trivaiate crosstab. So we'll go to Analyze, Descriptive Statistics, and Crosstabs, and we'll put uni degree in our layer field. So if you press OK there, it'll generate our Trivaiate crosstab. So we now have 2 partial tables, one for those without a university degree and one for those with a university degree. And we see that for those who do not have a university degree, 28.7% of those for whom religion is not very or not at all important identify as right-wing, and 34% of those for whom religion is very or somewhat important identify as right-wing, right? So the religious are 5.3 percentage points more likely to identify as right-wing than the non-religious folks, provided they don't have university degrees. Amongst those with a university degree, we see that 39.1% of those for whom religion is very or somewhat important identify as right-wing, versus only 21.2% of those for whom religion is not very or not at all important. So here, the gap is 17.9 percentage points. So we see a similar situation that we saw in the previous examples, where the gap starts out at 11 points, but once we control for the effect of education, amongst those with no university degree, the gap shrinks. The gap goes down to 5.3 percentage points. And amongst those with a university education, the gap increases. It goes to 17.9 percentage points. And so because the partial tables are split, one decreases in its gap, the other one increases in terms of its gap, we can conclude that this is another example of an interactive relationship. Does that make sense here? I really tried hard to find an example of an intervening relationship. Some of the examples got a little hairy and complicated, so I decided to just stick with this. But you know, I don't want to give the impression that every single relationship that you will look at on a trivariate basis will be interactive, but interactive relationships are very common in the world. Any questions there? So I want to point out another thing here, and that's when you run the trivariate crosstab, you get this total partial. And this total collapses all categories of Z, of our control variable or moderator variable. And very often, it ends up reproducing the result of your bivariate crosstab, right? So recall in our original crosstab, the gap was 11 points. Well, here, the gap is 11 points as well. What I would recommend is to not pay attention to this too much, because in this case, there are 1,243 cases in the trivariate crosstab and 1,243 cases in the bivariate crosstab. So the reason why this is exactly the same as the original bivariate is because there aren't any omitted cases between the two of them. But if you work through Lab 6 and Stats Coach, you'll find that you actually end up omitting some cases once you introduce the third variable, because not everybody answers every single question. Or if you're looking at a country data set, we don't have data on every single country for every single indicator. So don't rely on this total partial table. Instead, when you're comparing the partials of the categories of the independent and dependent variable, always compare them to the original bivariate crosstab, as opposed to comparing them to the combined total partial table. We'll do one more just for people to practice pointing and clicking. We'll do a slightly different one here. We'll do another ideology and public policy question, except this time we will look at the dependent variable, how much more should be done for Quebec. So there's number 17 here, more for Quebec. So this is a question where they ask, how much more should be done for Quebec? Much more, somewhat more, about the same as now, somewhat less, much less. And this is coded as 1 if somebody says much more or somewhat more, and no if somebody gives any other option. And our independent variable, we'll actually look at an ordinal independent variable. So we'll look at ideology categories. Variable number 15, this is coded as 1 for left, 2 for center, 3 on right. So let's do this. So we'll set up our crosstabs. We'll get rid of all of our existing variables. So we'll do do more for Quebec on our rows, that's our dependent, and we'll do ideology categories in the columns. And the theory here is that those on the left tend to be more supportive of government spending than either those on the center or those on the right. So those on the left should be more willing to do more for Quebec because they're more willing to spend government money. So I think that rationale makes sense on a logical level. So we'll run this crosstab, and we see that among the left, 22% say more should be done for Quebec versus only 9.4% of those on the right. So that's a gap of 12.7 percentage points, almost 13 percentage points. And those on the left are more than twice as likely to believe more should be done for Quebec than those on the right. There's other possible variables that might play here. Maybe whether or not somebody lives in Quebec. So we happen to have a variable for that. So variable number 11 is Quebec. A respondent lives in Quebec, and we'll code that as 1 if they live in Quebec, 2 or 0 if they live in the rest of Canada. So we'll run our Trivaiate crosstab, and we'll put is QC in our layer column or our layer box and press OK. So now we have a partial for the ROC or rest of Canada, a partial for those who live in Quebec, and then this combined partial, which we're just going to ignore. And what happens here? So among those who live in the rest of Canada, 11.3% believe we should do more for Quebec versus only 4.8% of those who identify on the right. So that's a gap of 6.5 percentage points. Among those who live in Quebec, 66.3% of those on the left believe we should do more for Quebec versus only 33% of those on the right. And obviously, overall levels of wanting to do more for Quebec are higher in Quebec versus the rest of Canada. But look at the ideology gap, right? Here, it's 6.5 percentage points. Here, it's 30 percentage points, right? And so, you know, we went from an original gap of just under 13 points in terms of doing more for Quebec. And that gap of 13 points has shrunk to 6.5 points amongst those outside of Canada. And it has grown to 30 percentage points amongst those who live in Quebec, right? So here's another really strong interactive or interaction relationship where introducing a third variable shows that the original bivariate relationship isn't the same across categories of our Z variable or control variable or moderator variable. So that is pretty much what I wanted to go over today. I'll give folks a chance to ask any questions here. Does anyone have any questions? Okay, great stuff. So if you wanted more practice, you can work through Lab 6 of the Statistics Coach. If you want an illustrated step-by-step guide on how to do Trivaiate crosstabs, you can look at Section 6 in SPSS Essentials of the Stats Coach. That's page 143 onward. Or you can consult this video, which I will upload as soon as Zoom processes it, and hopefully it doesn't take too long to process. Other than that, thanks for joining, and I'll be back Wednesday and Thursday at noon if you want to drop in and ask any questions. But thanks for joining, folks, and take care and stay healthy.